Hello guys, so first I wanted to find the elastic potential energy, which is the energy stored when the rubber band has been stretched. In order to find this, I needed the rubber band constant, which I found using the formula K is equal to F divided by X, or force divided by displacement. I conducted an experiment to find the displacement and measure the mass of several objects I used in this experiment. So for example, one object was 120.9 grams, and I had to convert it to newtons. So I divided the mass by 1,000 to find the kilograms, and 1 kilogram is equal to 9.8 newtons. And then I used the cross multiply to find the newtons. So as you can see in the graph, it's a relationship between displacement and force, and the slope or the K value was 19.23 newtons per meter. Then I plugged in the value into the formula, and I found that the elastic potential energy was equal to 0.0190 joules or newtons per meter. Then I wanted to find the rational velocity, which is the initial velocity plus acceleration times time. In order to find the acceleration, I conducted another experiment where I found that it was approximately 3 revolutions per second. So in 1 second, the velocity of the rubber band was 19.84 radians per second. Then I found the total displacement, which was the initial velocity times time, plus 1/2 of acceleration times time squared. In my results, were that the span of 3 seconds, there was approximately 13.5 revolutions. And I did 15 revolutions in my hopper, which equaled 3.2 seconds and the displacement of 30 centimeters. And as you can see in this graph, it's a relationship between the number of revolutions and the distance traveled. So in 15 revolutions, it traveled 7 centimeters, and in 15 revolutions, it traveled 14 centimeters. Yeah.